Hello friends, this is page 5 of your Mod 5 review. Okay, I'm going to dig right and maybe make it slightly larger, like that. Okay, so let's see here. What am I doing? Graphing a cubic. Boy, did we give you everyone? It seems like everyone's got an argument. Every problem. Anytime there's something happening underneath the radical, there's going to be this A column. Okay, so this one right here, our starting point. We did ask you for the starting point, but we didn't give you a place for it. So I'll make my own little place. Our starting point is going to be 1, 0. Okay, so over here for a cube root, unlike the square root, for a cube root, we want -8, -1, 0, 1, and 8. Those are the values we're looking for. So we'd like to figure out what we can put in here to get a 0 first, and that would be a 1. That gives us a 0 times 2 is 0. Maybe I should put that out here to make it easier for you guys to understand. Okay, so now to get a 1, I would need a 2 in there for x. If I put a 2 in for x, that gives me a 1. And now I've got the 2 times the cube root of 1, which is a 1, so this ends up being a 2. If I want that to be an 8 in there, I need this to actually be a 9. Then I'm going to do, if I put a 2 or a 9 in there, then -1 is 8, cube root of 8 is a 2, and this is 4. So if I want this to be a -1, then I need a 0 here. 0 minus 1 is -1, so this would be 2 times the cube root of -1, which is -1. It's a -2. I want this to be a -8, so I need a -7. It's going to give me a -8, so I'm going to have 2 times -2 is a -4. Rightio, let's go grapher. Sometimes I don't mind it, but this gets old really fast having to do these things. If another math teacher asks me, though, don't tell him I said that, or I'll deny it. Okay, so let's see. Make sure you're graphing the x's and the y's. 1, 2, 3, 4, 5, 6, 7. And I need to go down 4. This is -7. -4. It's really hard on these crappy graphs. There, I should probably do 0, -2, 1, 0, 2, 1. No, that doesn't seem right. 2, 2. Yes, that does. Sorry, just a momentary mind loss. 2, 4, 6, 8, 9 would be here. I'm going to go up 4. Now notice this is a little bit more stretched out than most of our cube root graphs, and that is because of that multiplier 2 out front. Normally from our starting point it'd be over 1 up 1, over 8 up 2, but we went over 1 up 2 and over 8 up 4. So if you're thinking that's a little stretched out, that's because it's a little stretched out. On this one they're not asking us for domain and range, right? Notice I did put 5 points. If you had only put these 3, that wouldn't be enough to really figure out what's going on, so you need to do 5 over here. Okay, if one of the points was like way off the graph in either direction, you don't have to do it. 4 would be enough at that point. All right, next one. Yay, we finally got one that doesn't have an argument. We only need to do an x and a y chart here. So I'm going to use -8, -1, 0, 1, and 8. And then simplify. So starting point is 0, 3. Okay, if I put a +1 in there, I get -1 plus 3. The negative is coming from this negative out front. So this ends up being a 2. If I put an 8 in, I get -2 plus 3 is 1. If I put a -1 under there, I get -1 plus 3. That ends up being a 4. If I put a -8 in, I get -2 plus 3 is 5. Okay, let's go graph this nonsense. Okay, so negative 8. You know what? I'm going to start at 0, 3. And then I'm going to go negative 1, 4 is here. I'm going to go positive 1, 2. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 up here to 5. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 and 1, I think. Yeah. Okay, let's graph her. Something like that. All right, friends, there she is. Isn't this fun? And then finally, the last graph. This one's back to needing an argument because there's nonsense happening underneath the radical. Cube root. Because it's a cube root, these are my wants. So starting point is negative 3, negative 2. So if I ask myself what would make this a 0, that's a negative 3. If I put in a negative 3, this becomes a 0, so I get a negative 2, which is where that starting point comes from. Okay, so if I want to make this a positive 1, then this should be a negative 2. And then the cube root of 1 is 1, minus 2 is negative 1. If I want this to be an 8, I need this to be a 5. If I put a 5 in there, I get an 8. The cube root of 8 is 2. Minus 2 is a 0. If I put negative 1 up in here, no, I don't want to put negative 1 in. I want this to be a negative 1, so I need it to be a negative 4. So then the cube root of negative 1 is negative 1 minus 2 is negative 3. And then if I want that to be a negative 8, I actually need a negative 11. Is that true? Should I just do that too quick? Negative 11 is negative 8. Cube root would be negative 2 minus 2. Okay, all looks good. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, this negative 11, I'm not even going to try and get on here. So that's what I mean. Sometimes only 4 values instead of 5 makes sense. So let's see, let's start at negative 3, negative 2. And now I'm going to do negative 4, negative 1. Is that right? No, it's not. Did not seem right because there shouldn't be a reflection there. Negative 4, negative 3 does in fact seem right. Blah, blah, blah. So that's how I knew what I was expecting to get versus what I actually got. Negative 2, negative 1 is right. And then 5, 1, 2, 3, 4, 5, 0. And how about negative 11? Don't care. Something like that. So there are my 3 graphs, all variations of the parent graph. I just got paper stuck there. Okay. All right, let's do a couple of these problems at the bottom. Rewrite the expressional, sorry, tired. Okay, rewrite the expression in rational exponent notation. So base is 17. The 4 goes up top in the numerator, and the denominator is whatever the index is. So that's rational exponent notation. Rewrite this little sucker in radical notation. So to do that, this is my index. So that's the 7th root of 23 to the 3rd. So the base is under the radical, the bottom is the index of the radical, and then the 3 is what your exponent's going to be. Evaluate without using a calculator. So this is a cube root of 64. 64 is 4 times 4 times 4, if you know that. Look at these weird lines. What did they do right there? Okay, whatever. 4 times 4 times 4. Oh, cube root of 64 is 4. Okay. You could have kept going if you needed to and then looked for parties of 3. If you broke these down to 2s and then looked for parties of 3, you would get 2 of them, which would come out and give you a 4 outside. Cube root of 125 is 5. Am I supposed to make that harder than that? I don't know. Okay, and then, ooh, this will get some of you. This is a negative 3. If you need to see something, let me see if I can show you something. I hear you, animal. Hold on. -3 times -3. This is a cube root, and this is a party of 3. And so that gives you a -3. Okay, friends. Yay, another page done.